name is Terry Becker. I am an electrical engineer. I reside in Calgary, Alberta. I'm a certified electrical safety compliance professional and an IEEE senior member. I'm glad to have the opportunity to present a webinar on NFPA 70E and CSA Z462 arc flash and shock and what I call getting it right. So we have an hour-long webinar today. Basically, I'll start by introducing myself. Again, I'm an electrical engineer. My background is oil and gas related experience. I now provide independent electrical safety consulting with my company ESPS Electrical Safety Program Solutions, Inc. I am the first past vice chair of the CSA Z462 Workplace Electrical Safety Standard, which is the Canadian equivalent of NFPA 70E. These documents are technically harmonized. I'm also currently a voting member, and I'm in charge of the Annexes Working Group for CSA Z462. And I attend and participate in the working groups for the NFPA 70E Tech Committee and their cycle in the US. I'm an IEEE 1584 Tech Committee voting member. In Canada, we have a new guideline on maintenance of electrical systems, so I'm an associate member on that Tech Committee. My company is involved in providing electrical safety consulting services, which includes electrical safety auditing, electrical safety program development support, low and high voltage and arc flash and shock training solutions, including e-learning for arc flash and shock. You can find out more information about myself and my company on the company's website, www.esps.ca. Just a bit of a disclaimer before we start the webinar. Because I am a voting member on the CSA Z462 Tech Committee, I advise people when I present that I am presenting today and providing you my personal technical and professional opinions related to CSA Z462 or NFPA 70E or some of the related standards and topics. If you want specific interpretation, you're encouraged to go to the actual documents themselves or contact NFPA or CSA for specific interpretations. So today I wanted to provide a broad sort of presentation about where we're at and where we're going, and at a high level discuss the new risk assessment procedure and getting it right, some of the issues that I see in industry that I think we all need to learn from in a continuous improvement model consistent with occupational health and safety management systems. We need to continually review what we're doing, ensure that it's correct or it is a viable and or appropriate interpretation. So again, today's agenda is just going backwards a little bit, talking about electricity and where we have evolved with NFPA 70E in the US and CSA Z462 in Canada. And again, hazards are neglected and some new information from NFPA on electrical injury statistics, the evolution of NFPA 70E, and now in Canada, CSA Z462, specifically this new risk assessment procedure requirement. Just a brief update on the IEEE 1584 standard, the work that has been ongoing for well over 5 years now to update it, and we should see a new edition provided at this point in time for my involvement in that tech committee beginning of 2018, I hope. Sort of the status quo for arc flash and shock, sort of some of my perspectives on what these hazards are, how they're being identified or incorrectly identified, specifically arcing fault and arc flash. Again, a bit of review of what is an arc flash and when is a worker exposed to electric shock, working on a new perspective, just some of my ideas that definition should be expanded a little bit. The risk assessment procedure, I'm going to highlight it briefly. There's more information required that can be covered in an hour on the risk assessment procedure, but I want to just highlight what my opinion is with respect to that procedure. We'll go through that briefly. Then again, getting it right, some sort of misunderstanding, misapplication comments, again, meant to stimulate thought with a continuous improvement model. And really the hierarchy of controls now identified in NFPA 70E and Z462 related to the risk assessment procedure, and that they're not being applied correctly or they're being applied with a misinterpretation or misapplication. Then just a bit of a wrap up on what I wanted to cover today, and as I said, we'll cover some questions at the end of the webinar. So again, electricity, we've used it for hundreds of years, and we didn't really manage the hazards. It's a global issue. It's just not North America. and huge problem. Even in North America, we haven't still done, what in my opinion, an effective job of shock specifically, arcing fault and arc flash hazards. A lot of attention spent there, and that's a good thing. But again, these are global issues, and again, the history is really in the North America context. To just go over that briefly. So in the 1970s, the Occupational Safety Health Administration Act, again, would have recognized that electrical injuries were occurring and weren't acceptable, and they were trying to address them through the National Electrical Code, but it didn't adequately address them. So we had, well, just stepping back, this is the American Electrician's Handbook, and this is the problem. Historically, we actually had electrical workers using their bodies as voltage detectors. So again, this was actually published and taught up till 1960, I believe, and again, for up to 250 volts, use your fingers to do the voltage check, and for balance signal wiring, use your tongue. And again, this is no longer acceptable. Was no longer acceptable in the 1960s and 70s. In general, other workplace hazards weren't acceptable, but specifically in the context of shock, this work practice was the way it was. And I do discuss that historically, electricians have been taught to take shocks, and here's an example. We taught them to, and so they have considered shock as not an electrical incident, when in reality it is, and it is a near-miss incident that could have resulted in electrocution. So this is sort of the past, and then again in the 1970s, OSHA sort of recognized that shock specifically needed more attention, and it wasn't being really managed by the National Electrical Code, so NFPA 70E was created. And then the arc flash hazard was further identified, and then content on arc flash was included in future editions of NFPA 70E. So again, the regulations changed to specifically address electrical safety and electrical hazards. NFPA 70E language is actually, in my opinion, embedded right in OSHA's regulations. They didn't adopt NFPA 70 into law, but they took wording and content which really implies that you use NFPA 70E as your base of due diligence to those OSHA regulations. So what happened is this evolution of 70E was occurring. We became aware of NFPA 70 in Canada. Specifically, I became aware of it in probably 2004 by attending an IEEE PCIC conference, I believe, is where I first heard of NFPA 70E. And what happened is CSA signed an MOU with NFPA, and they decided to harmonize NFPA 70E for Canada as the CSA Z462 Workplace Electrical Safety Standard. So we're in third edition of Z462 up here in Canada, and we are again harmonized. So if a company's in Canada and the US, we're speaking the same technical requirements as the basis of the requirements of identification, and now the risk assessment procedure and the related information in NFPA 70 and CSA Z462. Just as a word of note, in Canada, provinces and territories and federally, we have not adopted CSA Z462 into law, but what we're seeing is a trend in two provinces, Alberta, where I reside, and New Brunswick out in the east, that they may adopt Z462 in whole or part. So that's a significant change for Canada in the evolution of Z462 in its application in the industry. And again, the regulators, in this case, we regulate occupational health and safety provincially or territorially for most workplaces, and then federally under the Canada Labour Code Part 2. So most companies are regulated provincially or territorially, so we do have unique and different OH&S regulations, where in the US you have your overriding OSHA, and you might have specific state requirements above and beyond OSHA. So again, we've seen these hazards not being identified. That changed in the 1970s in the US with NFPA and recognizing through OSHA that there was a requirement to do some additional work. 70E came about, and again, it's evolved, and it's 10th edition, and we're moving to 2018 edition. So just some background information about electrical incident statistics. This has been an interesting topic as I've been reviewing this since 2004. When I worked for a large oil and gas company, they said, "Where's the statistics management?" I said, "Well, we can't really get them in Canada." And there was some available for the US, but they were provided by different organizations. So if you're not aware of this current report that was developed and put together in 2015, it amalgamates all electrical incident statistics for the US that could be found and compiled, and it provides a really good single point of information. for incident statistics. What I've highlighted on the left is that during a 20-year period, of the fatalities that occurred in the U.S., there was, I think, 5,600 roughly. 99% of those were electrocution. 1% were related to arc flash burns where the worker didn't survive, or 56 arc flash fatalities, right? So roughly 3 a year arc flash fatalities. Now that doesn't imply that arc flashes aren't occurring, because they are, and shocks are occurring, a significant number of shocks that we don't even hear about. Unfortunately, we only really hear about the fatalities. And the other key piece of information is there's no recorded fatalities due to arc blast pressure. Again, so we've seen this evolution. Here we have a report in 2015 which says that it is a problem, and we need to continue to do a good job and a better job of managing these two hazards, and we facilitate that through NFPA 70E and CSA Z462 and the related standards. So these are just a snapshot of the latest 3 editions of NFPA 70E and Z462 for Canada. Again, we did not have a standard for Canada until January 2009. The big change here is in 2015. The basis of these standards changed to risk-based language. It is a significant change, in my opinion, an excellent change, aligned with occupational health and safety management system standards, and really puts the context of identifying the hazards, assessing the risk related to a work task, and applying the hierarchy of controls formally to drive down the risk level of an energized electrical work task assigned to a qualified electrical worker. And then further to that, in 2018 edition, we're going to see some more cleanup of the risk assessment procedure. Not as big of a step change as we saw between the 012 and the 015 editions, with this complete cleanup of the document, being really hazard-based to now being risk-based. So that's, again, a significant change, and I applaud that it happened. I think it was the right thing. And once you understand it and in my opinion, apply the risk assessment procedure correctly, it provides a really good tool to analytically sort of say, are we doing everything we can to manage severity of injury, right, with boundaries in PPE? But what it does is, because the risk assessment procedure just doesn't look at severity or harm, it looks at likelihood of occurrence. It puts focus that we need to look at likelihood of occurrence at the same level of detail and importance as the hazard or the harm. So risk assessment, again, I've got some slides coming up on that, and I'll briefly review that. So we're seeing an evolution, and just if you're not aware, NFPA 70E is proliferating across the globe. Z462 and some, Australia and New Zealand might have some notoriety, but it's mostly the NFPA 70E standard. I probably haven't even covered off all the other locations, globally that NFPA 70 is being referenced or used or adopted. And that's a good thing, that this standard is being, again, taken across, the globe via U.S. companies or countries themselves that recognize that it's a great document. So very positive, lots of good activity in the last 20 years. We do have a long ways to go, though, a long ways to go. So OSHA, as far as OSHA, I just captured this screen because I thought this was actually an excellent screen. Is all the regulations are there, but what's happened is that this came up recently, is that OSHA's put some emphasis on occupational health and safety management programs. So again, OSHA regulates the workplaces in the U.S. Federally, and then there's specific state requirements. And as I mentioned, in Canada, we have individual province or territories. So this is just a shopping list of the applicable OSHA regulations that are related to electrical safety and arc flash and shock. And there was some work on 1910.269 here in the last several years for utility workers, so significant changes there. No real updates to the other regulations that I've just listed. So again, this is just a snapshot of where arc flash and shock hazards show up in OSHA regulations. In Canada, as I mentioned, we have every province or territory of individual regulations. These are just covers of handy guides, third-party published documents that provide the individual province or territory's regulations, and some explanatory information on due diligence. So again, 2 jurisdictions, Canada, U.S., occupational health and safety regulations managed differently. The U.S. has formal content covering off, again, arc flash and shock and electrical safety. Canada's a little weaker still, depending on the province or territory, with specific language on arc flash and shock. But as I mentioned earlier, some of the provinces are providing more information, like British Columbia. They have a whole section on electrical safety that they had. Unfortunately, well, fortunately, it focuses on shock, but it doesn't provide a lot of guidance on arc flash. They do have guidelines in Canada for some of the provinces on the regulations. They give you some additional information. So in British Columbia, they actually do advise an employer to informally review the Z462 standard, but they use the language may find CSA Z462 to be valuable. It's not formally adopted into law. So again, a little bit of information on British Columbia. In Alberta, this is an excerpt of the changes where they will be specifically identifying arc flash in an existing regulation related to flame-resistant clothing. They're going to uniquely identify it as arc flash, or that's the hazard, and arc-rated clothing, adopting ASTM F1506 into law, and 2 clauses from Z462. So part of Z462 is planned to be adopted into OHS law in Alberta. In New Brunswick, on the east coast of Canada, this is an excerpt from their working document reviewing their existing OHS regulations related to electrical safety. They may adopt all of Z462 into law. This is pending in 2017 or 2018 for both Alberta and New Brunswick. So this is a big step change in Canada if 2 regulators adopt formally Z462 into OHS law. Again, this is why you have to track these regulations. They really drive the level of due diligence that your company needs to sustain and maintain. So the IEEE 1584 arc flash phenomenon project that was kicked off with NFPA and IEEE is finally coming to a close. What happened here is they did 1,800 arc flashes in labs versus 300. The technical model has been updated. There's been some delay due to internal IEEE processes. We should see this published in 2018. There will be some changes, and you know, with the calculations, I'm encouraging engineers that, you know, review the changes. Make sure you provide credible advice to your clients on the need to update their studies versus completely redoing their studies. So I encourage all of you that are online that do studies, when these formulas change, temper your review of the formulas, temper your review of the analysis that's required, and provide, you know, valid information to your clients on it's going to, you know, take this much effort to update these studies. So again, there will be changes to the formulas, improvements, and in turn that will require a review of existing studies, but we have to temper that with, again, the clients that are out there and how much time and money is required to update these studies. So if you're not aware that this is coming, now you are. You know, EasyPower will have all the formulas updated in their software and ready to go. They probably have them updated right now, but they can't obviously release them until this standard publishes officially, which again, pending 2018. So watch for it. EasyPower will probably update their manuals and their review of the formulas as well. They do have good manuals for the software and good supporting documents. So again, look for that information from EasyPower. Make sure you review it. Make sure you temper how you present this to your clients in updating their studies. So this is just a little bit of a graphic. I'm trying to demonstrate that as far as risk assessment and then looking at arc flash and shock hazards, with the history I showed you, the inherent risk assessment was high. We didn't have any PPE, and really that drove the risk level to high, because had workers been exposed to arc flash, their clothing would have ignited. But what we saw as safe installations came along, the National Electrical Code, the Canadian Electrical Code, that helped out on that side of things to deal with shock, right? And again, the National Electrical Code does include content related to arc flash, where the Canadian Electrical Code doesn't. Maintenance practices are being reviewed. This is another improvement. And then now with the latest editions of 70E and Z462, we have the new risk assessment procedure. So we didn't have you know, energized electrical work being performed that I would call low or high risk historically. Through the evolution of OSHA, NFPA 70E, NFPA 70, the National Electrical Code, Canadian Electrical Code, we've had you know, a raft of improvements in the last 30 or 40 years. The latest editions of 70 and Z462 embed this risk assessment procedure and take it to the next level. So on the left-hand side, we now want to formally apply the hierarchy of controls identified by Occupational Health and Safety Management System Standards, ANSI Z10 for the US, CSA Z1000 for Canada, to drive the residual risk level after you apply the controls to, in my case, what I call lower medium risk. An appropriate due diligence applying 70E would require this new risk assessment procedure to be utilized to formalize the application of the hierarchy of controls. And I for lack of occurrence on the top left, I've highlighted 3 really important probability components of likelihood of occurrence: qualified and competent workers, human performance behavior, and condition of maintenance. In the 2018 edition of NFPA 70E, there will be a new annex on human performance behavior. It is a critical element of risk, human error, right? And there will be some language added to the articles for 70E and the clauses for Z462 to place emphasis on the need to manage human performance behavior formally. It is a key element of the risk level of a work task. So historically, companies bought PPE and they sent their workers on training and felt that that was good enough. They got studies done, installed equipment labels, and thought that was good enough, but it's not. Ultimately, my opinion is an electrical safety program should be developed, and it drives the application of the controls, getting the studies done, buying the PPE to a specification, right, and then also specifying the training and the application of the other controls is delivered through an occupational health and safety management system and electrical safety program. So if we continue to make these improvements from the bottom up, we will take the residual risk level of work tasks to lower medium consistently. So just going backwards, what's an arc flash? It's an arcing fault. It has to occur and it has to be uncontrolled. So we have controlled arcing faults or arcing in equipment, which is fine. It's part of the design of the equipment. When the arcing fault's uncontrolled and due to abnormal conditions, and we have, again, the right voltage level, it's high enough, and the system capacity, we can create an arc flash event. It's probabilistic, work task-based interaction, and or abnormal condition, as an example, contamination with no worker interaction. 70E and Z462 are work task-based documents. The whole discussion needs to start with what is the work task being performed on the energized electrical equipment. All right, so again, electrical workers are exposed to arc flash. Non-electrical workers should not be exposed to arc flash due to their work tasks, or again, the equipment not being in a normal operating condition. So through maintenance, we maintain energized electrical equipment in a normal operating condition, and we can have people operate it, stand in front of it, right, be there, and they don't need arc flash and shock clothing on. And I'll discuss operating maintenance and repair and alteration and isolation in a slide coming up. So we've got these equipment labels from the studies. There's lots of those going up. We need to make sure workers understand what the information means and when the information applies to their work task. That's really important. So this is just a graphic that shows the arc flash boundary for quick review purposes. Again, when the calculation's been done or you use the new arc flash PP category table method, you'll achieve an arc flash boundary distance. Workers outside that boundary don't need arc-rated clothing on. If you're inside the boundary and you are doing an energized electrical work task that could create an arcing fault, then you'll have arc-rated clothing on with an arc thermal performance value. So this is the working distance. That's part of the calculations. You'll be very familiar with this. So for low voltage equipment, the working distance is 0.45 meters. For medium voltage switchgear, it's 0.6 meters. And for high voltage switchgear or MCCs, it's 0.9 meters. And those are the default working distances in the IEEE 1584 standard. So a graphic of an arc flash, probably seen this before. We get this ionization of air between conductors. We get an arc, right? And it converts to an arc flash quickly, very quickly. And then the effects or harm that can come from this arc flash is, again, we get that heat that comes off. We get expansion of air and copper, which creates pressure. Again, the point of the arc could be 35,000 degrees Fahrenheit or 20,000 degrees Celsius. We get UVR light. We can get some molten metal coming off of it. Sound waves up to 165 dB instantaneous. So we get these, toxic release of energy if we get an arc flash, and that's why we want to put on PPE when and if we believe a worker is doing a task that could create this arcing fault. And if the equipment was in an abnormal condition, then you would maybe also put on the arc flash clothing just because you don't have normally operating equipment. This is a boundaries graphic that I've created. It's sort of a snapshot of NFPA 70E or Z462 on one page. When we do the arc flash risk assessment and the shock risk assessments, we establish these boundaries. But as far as the risk assessment procedure, within these boundaries, we need to apply the hierarchy of controls to reduce the risk level to as low as reasonably practicable, right? So it's just a one sort of snapshot drawing to put all that information from the arc flash and shock risk assessments together in a visual aid for reference. But the key and the big difference is, you see I've got a lot of risk language on the boundaries graphic, as this new risk assessment procedure is independent of the arc flash and shock risk assessments. It's a little bit of a piece of information on arc blast pressure, and that's Dr. Ralph Lee's graph on the right-hand side. Dr. Ralph Lee's an electrical engineer from Edmonton, Alberta, and he was doing some of the initial research and development of formulas. And what I'm emphasizing here that is 40 calories per centimeter squared is not a dangerous incident energy level. I call it the 40 cal myth. This has had misinformation that's occurred. Remember, I said I want continuous improvement. I want us to evolve in our understanding. Well, here's a discussion point. 1.2 calories or greater than 1.2 calories is a dangerous incident energy level when workers aren't wearing arc-rated clothing. Arc blast pressure does not correlate to incident energy. It correlates to arcing fault current, as illustrated on this graph. So the key is we can work up to 140 calories per centimeter squared because there is an arc flash suit available from Oberon Company with that arc thermal performance value. Clothing, whether it's an ATPV of 8 or 140, performs the same. 50% probability of the onset of a secondary burn. So again, arc blast pressure correlates to arcing fault current and distance, not incident energy level. Unfortunately, this problem or this misunderstanding was exacerbated by the power engineering software, including the hazardous category tables to correlate to the incident results to define PPE, and that wasn't technically correct. All of the software has now removed that correlation between the results table and an HRC because PPE is not stipulated historically by a hazardous category when you do incident energy analysis. When you do incident energy analysis, arc-rated clothing is specified by its arc thermal performance value. This has been a misunderstanding, and I'm using today's webinar to provide a little bit of education, and hopefully, again, the mindset you should have is learning more and again, growing in your understanding of arcing faults, arc flash. In this case, this is my opinion about arc blast pressure. So I've got some videos. I'm just going to exit out, and we'll hopefully get these to run. So what we're going to look at this video, and it's a good video of why we have high-risk work being performed out there. There's no sound. This video is some workers in a substation in the Middle East, and the problem is there is no risk assessment, there's no arc flash risk assessment, there's no shock risk assessment. So again, there's no audio. This is high risk because we have a worker doing energized repair and alteration in an MCC starter bucket, and he has no formal arc flash risk assessment or shock risk assessment. The two other workers are confining him. The two other workers are actually talking over top of him. His human performance behavior is affected, and he is not on task. Another worker walks into the scene, could also walk into this work environment because there's no electrical work zone with red tape created. The arcing fault arc flash is coming, right? Fortunately for all the workers there, it was a low incident energy result, probably less than 8 calories. The worker with his hands in the bucket doing the energized repair and alteration for digital metering, manipulating conductors and circuit parts, was burned in the face and hands. So there's the arc flash. Now you'll notice the gentleman that has no PP on, he's hanging onto the MCC door, and now there's another gentleman who's leaning on the wall with blue coveralls, but the guy put his head into the bucket. There's going to be a secondary arcing fault occur here. Watch. So when there's an incident, get away from the incident area, and then safety equipment. Now the other problem that occurs here is they all walk away from the incident scene. So they should have had someone remain, maybe the guy in the blue coveralls, to make sure no one else went into the area. So again, as far as arc flash, right, what we're trying to do here is define it now by risk level. There was an arcing fault probability. He was doing energized repair and alteration, which, first of all, shouldn't have been done energized. But again, there was no practices. So what happened is the worker proceeded to do the work. So what I've got next is I've got a video from Westex. These are available on the internet. To me, this is a really good video from Westex. that provides a general overview of the arc flash hazard and PPE and why PPE works when it's not arc rated versus when it is.
An electric arc flash is a dangerous release of energy created by an electrical fault that contains thermal energy, molten metal, pressure waves, acoustical energy, and debris. Until we began to capture arcs with super slow motion cameras, the molten metal component was less apparent, but is a significant ignition hazard. The thermal energy released in arc is expressed in calories per centimeter squared. A typical arc flash will release energy from a few calories up to 20, and exposures between 20 and 40 calories are not uncommon. Everyday clothes made from cotton or polycotton fabrics can be readily ignited at these exposure levels, and once ignited, they will continue to burn long after the arc flash is over, dramatically increasing the extent and severity of burn injury. Several years ago, it became apparent that NFPA 70E was growing rapidly, would be the primary standard of the future, and that a large number of maintenance and electrical workers would be affected. Westech recognized in 2003 that existing arc flash work was focused on the utility environment, which is quite different from the typical industrial arc event. So, we made the commitment to invest in research with common industrial electrical gear to better understand, quantify, and document the industrial arc flash hazards faced by workers every day. As far as we're able to determine, the work of this test series is the first of its kind and scope in the world, and we're happy to be able to share with you. This includes a new series of arc flash videos shot in super slow motion at 3,000 frames per second, which is 100 times slower than standard video.
What I want to do here is these slow-mo videos are good, but you got to realize that it's slow motion. What they're trying to do here is say that there's shrapnel that comes off molten metal, and that enough of it could accumulate on non-arc rated clothing to ignite it. But you have to realize that this arc flash plasma cloud, it pushes over the mannequin. It doesn't bend around the mannequin. So the arc flash exposure is frontal here. But when you see these slow-mos, it looks like it could fully envelop the worker. In this case, it is not. It's a frontal exposure. It is very fast. But what they're doing is trying to say there's a lot of shrapnel or molten metal that could ignite non-arc rated clothing.
Technology allows an unprecedented look at industrial arc flash and an outstanding look at projection of the molten metal. Westech worked with Mike Wright of 70E Solutions to custom build a one-of-a-kind sled with a common 480-volt bus at the bottom and 30, 100, and 200 amp disconnects installed above. We created the arc flashes by placing a tool or a wire across all three phases. Our goal was to create real-world arc flashes using common 480-volt electrical equipment to help companies better understand the magnitude of the arc flash hazard that exists in nearly every facility in the world. There are a number of critical differences between most utility arc and most industrial arc, and while some of these differences have been understood theoretically, little of any field work has been done to demonstrate and characterize them. There are also key differences from arcs created in a Faraday cage in a lab and arcs created in real equipment. It was these differences that we hope to better understand and document. The learnings illustrated by the events on this video clearly demonstrate that industrial arc flashes are extremely hazardous events, despite lower voltage versus utilities, and that there is no situation, regardless of hazard analysis data, where you can be assured that non-flame resistant clothing will not ignite, regardless whether the fabrics are blends or 100% cotton. Arcs were captured with no mannequins to fully capture the event, with mannequins wearing 100% cotton and polycotton, and with mannequins outfitted in Westech ultra soft flame resistant clothing, both new and after 100 industrial launderings. The stripes and numbers that you see on the wall represent each of the arc gaps to illustrate the hazard zone. Safety professionals and engineers from many Fortune 500 companies, training centers, and leading unions were in attendance to experience the arc flashes in person. The testing clearly demonstrated that if you work on or near energized parts and equipment, flame-resistant protective apparel and other PPE can and does dramatically reduce injuries and save lives.
So again, that's a great video from Westech. Again, it provides us a guidance that non-arc rated clothing will ignite. If it's poly cotton blends, it'll ignite and melt. Again, that there is some shrapnel that if it accumulates could burn holes in non-arc rated clothing or possibly ignite non-arc rated clothing. This video is again another security cam video. I call it no look, listen, and smell. And again, when I show these videos, it's all about the risk. So again, what was the risk to the worker here? And again, in this case, the worker did not recognize an abnormal condition on energized electrical equipment, and you're going to see them exposed to an arc flash. So what I'm going to do is I'm going to accelerate it a little bit, and we see a worker come in, and what happens is he is identifying by either smelling or hearing an abnormal condition on an MCC starter bucket. So I apologize for the granularity of the video, but there's no sound. He went in twice. So he's gone in twice now, and he's still in front of the equipment. There is a failure about to occur, but he did not react to it properly. So he goes off screen, and then I'm going to fast forward it. He comes around, he's walking around, possibly looking for someone. He walks in front of the equipment in an abnormal operating condition again. So he's exposed about 3 times so far. He does the roll-up door, trying to find someone. He's going to come back, and he's going to go in front of the electrical equipment again. 4th time he's exposed where he could have reacted. You're going to see an MCC starter bucket, arcing fault, arc flash. Unfortunate incident. The gentleman had every opportunity, at least 4 times, where he could have removed himself from the exposure. So the risk was identified but not controlled. This last video is about contamination of PPE. So the arc flash suit that you're going to see is an Oberon Arc 100 or 106 cal suit. I was able to work with a client on a large coal-fired power plant, TransAlta Corporation, and they allow me to use this video. This was a coal-infused arc flash suit. We wanted to make sure that it would perform with the coal that was in it and contaminating it. So what we want to see is that the after flame extinguishes, it self-extinguishes in a relatively reasonable amount of time, which it does. So we only had a test of 1. We couldn't afford to do any more. These tests are expensive. But the coal, it looks like it flashed off, or it wasn't contaminated to the level where it degraded the performance of the arc flash suit. That's what an arc flash suit will look like. That's what the arc flash suit hood lens will look like. It takes the heat, absorbs it. Heat continues to go through the garment, but only enough heat for the 50% probability of the onset of a secondary burn when you're exposed at the arc thermal performance value of the garment, the arc-rated garment. Now, moving on, shock. So briefly, shock, exposed conductor and circuit part, inadvertent movement risk is the important classification here. And qualified electrical workers and non-electrical workers are potentially exposed. And remember, NFPA 70E and Z462 are all workers, qualified persons and unqualified persons, so it does address non-electrical workers and their potential for shock. And again, the report that I showed you from NFPA highlighted that as far as fatal injuries, 99% of the fatal injuries in the U.S. over a 25-year period were electrocutions, 5,587. So basically, we are seeing electrocutions occurring, unfortunately, at a very high frequency. And we still need to do a lot of work on that. That's overhead power lines, power line technicians, electrical workers, and non-electrical workers getting shocked and fatally electrocuted. So the shock approach boundaries, just another refresher, there's 2 boundaries now only. In the 2015 edition of 70E, prohibited was deleted because it was redundant for PPE from the restricted approach boundary. So here's my new classification for working on. I've added operating and isolation. So operating is not maintenance. Operating energized electrical equipment is not maintenance, and under normal operating conditions, no arc flash or shock PPE is required to operate energized electrical equipment. Diagnostics and troubleshooting is maintenance. Repair and alteration, again, energized, justified, requiring energized electrical work permit is going to expose a worker to arc flash and shock. And I broke out isolation. So isolation work tasks are racking in or out power circuit breakers or high voltage motor starter assemblies or installing temporary protective grounds. Those are not maintenance work tasks. Those are isolation work tasks. So when we review energized electrical work tasks, I've now broken it out into 4 classifications instead of the 2 that are currently defined in NFPA and 70 and Z462. So just, again, I'm trying to continue to work in industry so that we continue to understand when workers are exposed, when they aren't, and what is maintenance and what is not, and what normal operating conditions are and abnormal operating conditions are that are now defined in NFPA 70E and Z462. So a qualified electrical worker must apply the requirements of a company electrical safety program. They assess and confirm their work task risk level now, and if it's low or medium, then they can proceed and do the work. It's a yes-no decision. Training's provided. The risk level is determined by the employer with the employee participating together, but we do need to train the employee, the qualified person, on how to do the risk assessment procedure, and it can be completed in the field if required. And then in the field, the qualified electrical worker or qualified person must validate the risk level by confirming that they're applying the hierarchy of controls to the specific work task. So it always was about the work task in 70E and Z462. The new updated ARC Flash PP category tables, the first table 4A in Z462 or table 137, C15AA and 70E are changed, and they put the determination of ARC Flash PP based on condition of maintenance, a risk-based decision, into the hands of the user of the table, but they do define any equipment conditions, normal or abnormal operating conditions, determining the need for ARC Flash PP. So we need to understand, again, when a worker is doing energized work and exposed to an arcing fault in an arc flash or to a shock hazard. So can we do energized electrical work? Yes, we can. Is the risk level acceptable? Yes or no. If the risk level is acceptable, the qualified electrical worker or the qualified person completes the work task. This has not changed, but the risk assessment has, and our viewer perception has changed. So I'm finding in industry that there's a belief that operating energized electrical equipment is an inherent arcing fault probability, and it's not. So we need to manage our perception and our thinking and our understanding of arcing fault and arc flash probability, and use this risk assessment procedure to help us make those decisions that are credible, practical, reasonable. So there's the new risk assessment procedure. This is the same article in NFPA 70E. There's 3 things that the employer would need to do with the employee: identify that the worker is exposed to arc flash and or shock, assess the risks related to the work task, and implement risk controls following the hierarchy of methods, which is listed below in Note 1. These 6 things are the hierarchy of controls, recognized in Occupational Health and Safety Management System standards and by OSHA, OH&S regulators in Canada. We want to de-energize and eliminate the hazard first. We want to substitute with other materials, process, or equipment. Engineering controls would be doing incident energy analysis and applying mitigation as an example. We want to increase awareness by warning signs and barricading. We want administrative controls, training, and procedures. And PP is last, including measures to ensure its appropriate selection, use, and maintenance. Thus the coal contaminated arc flash chute, which wasn't really appropriate. So again, this is the new requirement. This is no longer electrical hazard analysis. It's a risk assessment procedure, and it has to be and shall be documented in a company's electrical safety program. Normal operation is defined. This is the clause in Z462. It's the same content of the article in 70E. 5 things: the equipment's properly installed, the equipment's properly maintained, which is subjective, all equipment doors are closed and secured, all equipment covers are in place and secured, and there's no evidence of impending failure. In the video, the worker did not recognize the impending failure and was exposed to an arc flash, unfortunately. So if we have these conditions, then energized electrical equipment is in normal operation. That's important to understand, but we can't be too conservative with some of this assessment. So again, the evolution of the standards, the new risk assessment procedure, right? This is a simplified flowchart of a risk assessment procedure. You've got to establish the context, energized work task. Then we want to identify that there's arc flash and shock hazard. We want to do risk analysis to determine an inherent risk level. Then we want to do risk evaluation. We want to apply controls. We want to get the residual risk level. And then we want to make sure we monitor and review the controls that we're applying to achieve the residual risk level. We need communication, right, to the workers, and it's a continuous process, right? So you need to reassess the risk because the equipment could be in an abnormal condition when the worker arrives to work on it, and then therefore the risk level may change. So these are examples of risk assessment matrices. I just went to the internet and Googled risk assessment, and you get all this information. So risk assessments can be of different, different analytical processes. You can see several different risk matrices. This is a simple risk register table and an electrical hazard risk assessment matrix based on Annex F in NFPA 70E or Z462. And again, I've completed one here, and you have to go through an analytical process. You quantify severity on the left with values, and you look at likelihood of occurrence on the right-hand side of this matrix, and there's 3 sub-elements of likelihood of occurrence defined in NFPA 70 and Z462 Annex F: frequency that the worker is exposed, the probability of the event occurring, and the ability to avoid. And then you do an inherent risk assessment. In this case, I've created a baseline with no PPE. Then we apply arc flash and shock risk assessments to achieve a residual risk level. The inherent risk level, and you see there's a high risk level related to arc flash in the example, not acceptable. We do arc flash risk assessment. We can drive harm down to 50% probability of the onset of a secondary burn. It becomes a 3 from an 8 value, and you have to follow, again, in this case, a summation process. I don't have enough time to go through this in detail. That could be another webinar, but this was an example of the actual risk assessment procedure. You need to do this analytical process and look at both severity and likelihood of occurrence, and then come up with a risk level, and the residual risk level must be acceptable. This risk assessment can be done in committee. This is a spreadsheet where a committee sat down and did a very detailed and comprehensive risk assessment against the generic work task list in Table 4A or Table 137.15 CAA. So getting it right. So just some comments to sort of bring the webinar to an end. I sort of wanted to say that, all this information and the context of 70E, it is positive, it is good. It is making a positive benefit for reducing, the incidents that are out there, but we still have them. And the problem is you need to make sure that, NFPA 70E or Z462 is being used correctly and reasonably. So the risk assessment process, it is a positive and defendable process, but we need to make sure that it is applied with a reasonable and practical perspective. It is a subjective process, so that's where you could, skew off and have an opinion that may say it's high risk when it's possibly not. And we've got to, make decisions based on facts, not fiction. So the risk reduction is accomplished by applying the hierarchy of controls. We need to be reasonable and practical in assessing and implementing those controls. Misunderstanding or misapplication will not achieve the intended results, which is ultimately having the risk level reduced to as low as reasonably practicable for the qualified person performing the energized electrical work task that we need to have completed. So again, these hierarchy of controls come from ANSI Z10 or CSA Z1000, Occupational Health and Safety Management System standards, which are now embedded formally in 70 and Z462. So here's some comments about some of the gaps we have. Companies do not have electrical safety programs developed, implemented, and audited. There's still issues with lockout, tagout out there that I see. Operating, opening, closing, turning on or off, perceived as arcing fault, high probability under normal operating conditions, and it's not true. I have companies and CEOs of organizations telling me, well, we just implemented a policy that we don't work live. We're okay. We're compliant. My electricians don't work live. And it's not a true statement. Every electrician owns a digital multimeter and does voltage and current measurements, and those are energized electrical work tasks. So we've got to manage some of these perceptions, this misunderstanding, this misinformation. What I am seeing that's really good is I'm seeing gas-insulated switchgear being applied, arc-resistant switchgear, arc-free MCC designs, arc-quenching technologies, high-resistance groundings are all being considered as substitution or engineering safety by design solutions. So again, good things, bad things. There's a lot of good coming out of this. The studies are driving a lot of this as well. So the upside of the studies is not only the equipment labels with the arc flash and shock data, but new equipment or upgraded equipment being installed. Our scanning windows and viewing windows are being installed. We're seeing ultrasonic inspection ports being installed. Companies are hopefully, and I've seen it, specifying more insulation, more guarding, and more finger-safe components, and new technologies are evolving. So there's lots of good stuff happening. On the incident energy analysis studies, forgive me for being critical, but I'm seeing some studies with conservative operating modes, the 2-second guideline or rules not being used, the wrong working distance are used, 18 inches is used for high voltage, it's very conservative, and the hazardous category numbers are used in the reports against the results to provide guidance on PPE when they technically never should have been used. So we've got some issues with conservative interpretation of less than 240 volts still. There's fear and miscommunication of arc blast pressure in training and facilitated through the studies when the results say dangerous, there's no PPE available over 40, which in reality there is. There's arc flash suits up to 140 cals. So if you have performed studies, I encourage you that you shouldn't be reporting 40 calories per centimeter squared or greater than that as dangerous. You should actually report out the actual incident energy calculated to the client, and the client will decide where they cut off work. Do not let the software make that decision for you or for the client. There's the graph about arc blast pressure again from Dr. Ralph Lee. I'm seeing equipment labels that are unacceptable, wrong information, misinformation, too much detail, or not enough detail. And HRCs shall not be included on equipment labels. They never should have been, and this has been rectified in the latest editions of 70E and Z462, that equipment labels will either have the incident energy or the arc flash PP category, but not both. And then we will see some significant changes potentially in the next release of IEEE 1584. So here's some examples of labels that aren't acceptable. 0.39 calories, danger's up there, explosion's going to kill you. 0.39 calories, you don't even need arc-rated clothing. Again, here we see a label greater than 40 cals, right? Refer to site safety program for guidance, right? So that's a good thing, right? They're saying you see the company's requirements for guidance when it's greater than 40. This label uses old language. It's just not a good label. Here's a label that the information actually has been, over time removed from the label. This label, 11,952 calories per centimeter squared. It's ridiculous. This totally discredits the study when the label includes the incident energy at that high level. The 2-second guideline was not applied to that study. And you got hazardous category D on there, which I don't even know what that is because it's not defined in 70 years Z462. Here's a label again, 152 cals. Incident energy at this location exceed the maximum. Energized electrical work's not recommended, dangerous. Again, if a company does define that, great. Here, there's an MCC with labels on everything. And it's just an authorized keep personnel out label. Here, there's a whole bunch of labels, too many labels, not necessarily good. And again, same facility, no labels on another MCC at the same facility. Lack of consistency on getting the studies done. So training, it's arc flash awareness, and it's, what about shock? I see too many titles of training where it just says arc flash awareness. The word shock is not included in the title. We need to make sure that shock is in the training. Fear used as a tactic of training is not good. The risk assessment procedure is misinterpreted. It's just not, completing an arc flash risk assessment and a shock risk assessment is not the risk assessment procedure. Procedures are not written and used by qualified electrical workers. Human performance behavior is not formally addressed. Electrical equipment maintenance has been neglected. Budget not established for that maintenance. The knowledge of electrical equipment maintenance is missing. If there's no electrical staff, management's unaware because the electrical equipment never fails. So the new risk assessment procedure would put emphasis on the need for defining specific electrical equipment maintenance and focusing on protective devices, breakers, and relays. The PPE, here's some of the problems I see in industry. It's not available when the equipment labels have been installed. If it is available, it's not managed properly, it's not stored properly, it's not tested current to establish frequencies. There's performance issues with these lab coat style arc flash suit jackets that open when you bend down. There's no budget for purchasing and updating new PPE. There's no hood ventilation systems on the arc flash suits. The electrical worker's not accepting the PPE, and they make excuses why not to wear it. These are all issues the employer has to deal with. So again, these hierarchy of controls, there's issues we need to manage in industry to get the benefit of achieving that risk level, that residual risk level being low or medium. To close things off, there's some new PPE tools and equipment out there. Fluke has some devices with remote displays that are removable, so the worker's frequency of exposure goes down. Excellent. There's a voltage tester, right, or that you can actually test your high voltage proximity detector with instead of using a fluorescent light fixture. That's on the bottom right. There's probe extenders from Fluke that you can actually get the worker's hands further out of the box. That will reduce risk of shock or arcing faults with conductors accidentally being hit by the hands and where they're not terminated properly pulling out of the equipment. This is a proving unit from Fluke. So test before touch. You need to find a defined source to test your test instrument. Fluke now has this independent source for AC or DC available. You don't have to use a receptacle anymore. You take this source with you and you can test your test instrument and get a positive 240 volts AC or DC with the Fluke PRV 240. This is new technology that's evolving from a company in Canada called Proxy Band. This is wearable electrical field detection, active detection on all the time. So if you think you've turned off the power and there's no voltage present and you go in with your body, this will vibrate on your hand. It will tell you that the field is still there. This is new technology. This won't be available for a year, but this is what's happening. We're getting innovation in PPE. This is preventive PPE. And then as far as the arc-rated clothing, There's now true color gray shields, face shields, arc-rated face shields, and arc flash suit hoods that don't discolor wiring. Don't discolor wiring. This is available from Oberon Company. It is, again, the best for the worker to wear to reduce the risk, the probability of human error is reduced with better PPE where they can see the wire colors as they should. So just to conclude the webinar, our understanding of electrical hazards has evolved. We no longer accept exposure. The regulations and the laws of the land have changed, right? And that's, again, a positive thing. U.S. OSHA and Canadian laws are developed. They're evolving. We do have North American 70E and Z462 being adopted. There's international changes, and they aren't necessarily using 70E, so we have to manage those and understand that the difference of opinions between Europe and Australia. In Canada, OH&S laws may adopt Z462 and whole or part into law. Our understanding of arcing fault and arc flash is still evolving. Shock needs to be a higher priority. Statistics prove this. Low voltage, less than 240 volts is still a gray area. Lots of opinions on arc flash. Let's keep an open mind with respect to arc flash. Use the new risk assessment procedure, make decisions. A good tool. Like of occurrence is important, always has been. Severity of harm and like of occurrence are both evaluated with the new risk assessment procedure. We need to get it right. So again, in the interest of time, and I've probably ran over a little bit late, I want to thank everybody for participating. I appreciate you for listening in. This recording will be emailed out to everybody that did register. And again, if there's additional questions, please get back to me or to EasyPower, and we'll provide answers.